Okay, we're going to look at the three different ways that heights of a triangle can appear. So consider three sides of this triangle, and this piece, this weighted length of chord, is the height. Right now we're looking at a triangle with a horizontal base, although any side of the triangle could be considered the base. We're going to look at the heights for this first triangle with a horizontal base with the vertex at the top. We're going to look at the different ways that heights can appear in, on, and outside of triangles. This obtuse triangle has a height outside the triangle. Now, the definition of the height of a triangle is the perpendicular segment from any vertex to the line that contains the opposite side. We don't just say the opposite side, because not all triangle heights are perpendicular to a side. The acute triangle has a height perpendicular to its side, which in this case is horizontal. But when we open up that angle and we look at one of the heights for this obtuse angle, we have to consider the whole line, the line that contains the base, because this height isn't actually perpendicular to the base, but it's perpendicular to the line that contains the base. It actually falls outside the triangle. So we've gone over the acute triangle, which has a height inside the triangle, and that doesn't have to make it a bisector of the base. It's kind of interesting that it would be a bisector of the base if the triangle were isosceles, but the less isosceles the triangle is, the less of a bisector its height is. And when we get to the right triangle, that height actually falls on a leg of the triangle, which makes a little bit of sense when you think about the definition of the height of the triangle as a perpendicular segment from the vertex to the base. The two legs of a right triangle are perpendicular to each other, therefore one of them has to be the height, and that's true for both legs of a right triangle. They can both act as a height. But the obtuse triangle's height falls outside the triangle. So what I'd like you to do now is draw these three examples. So let's start with the acute triangle. Try to draw a non-isosceles acute triangle and label its height inside the triangle. Mark the intersection with the height and the base with a right angle square in your drawing, and stop the video until everybody's had a chance to draw this acute triangle with a perpendicular segment that we'll call the height inside the triangle, and then hit play when everybody's drawn this triangle and labeled its height. Now that everybody's drawn the acute triangle with the height inside the triangle, we're going to draw the right triangle with the height actually on a leg of the triangle. Don't forget to mark the intersection of the height to the base with the right angle square. Stop the video long enough to draw this example of a triangle's height. Label this perpendicular leg H, and then restart. Stop the video long enough for everybody to draw this and restart, and we'll look at the obtuse triangle. Now we're going to draw the obtuse triangle with the height, the perpendicular segment that runs from the vertex here, perpendicular to the line that contains the base. This height actually falls outside of the triangle. So draw yourself an example of an obtuse triangle. Draw a height segment that is perpendicular to the line that contains the base and label it H. And stop the video long enough for everybody to draw that, and then we'll recap. Okay, so to recap, the definition of the height of a triangle is that segment that is perpendicular to the base from any vertex of the triangle. Now remember that in this example, the base happens to be horizontal, but that doesn't have to be true. So in another example, you'll be asked to draw heights from every vertex, because for every triangle, there are 3 heights. The obtuse triangle has a height perpendicular to the line that contains the base, and that height falls outside the triangle. The right triangle has a height that is actually a leg of the triangle. The acute triangle has a height perpendicular to the base and lands inside the triangle. The isosceles triangle has a height that actually bisects the base, makes 2 congruent segments because it is a line of symmetry or fold line or line of reflection. There's another right triangle with a height perpendicular to the base, and an obtuse triangle with a height perpendicular to the line that contains the base that falls outside the triangle. That is our Heights of Triangle lab.